All right, so problem number 37 on the review sheet. It's the first thing we're looking at. And we're going to look at whatever you want. Student IDs at a certain school consists of 2 consonants followed by, consonant, consonant, vowel, followed by 3 non-zero digits. How many IDs are possible if no repetition is allowed? Okay, that means nothing can repeat. So, how many consonants are there? 21.
Is Y?
Sorry. Listen, we're sticking with A, E, I, O, and U, regular.
Okay.
We're not getting all weird and funky. Okay, just regular consonants and vowels. Now, if nothing can repeat, then the next consonant has to be 20. Now, this is a vowel, 5. This is a non-zero digit, and they can't repeat. So that right there, all times together, would be it, right? Okay. Now, no letters can repeat. So the format is exactly the same, but no letters can repeat. So this part would stay the same. Would you agree with that? But then these are going to become 999 because there's no restrictions on the numbers other than they can't be 0. And then no restrictions at all. So no restrictions at all. Now the license plate, the ID has to have this format. But if there's no restrictions at all, then this would be 21 and 21 and 5 and 999. Again, those are all multiplied together. Okay? All right, Lucy?
Can I still ask one from the review sheet because I wasn't here?
You can ask from the review sheet as long as I haven't done it already.
Yeah, can you do 19?
19. Write as a fraction. Okay, so that means that the 5 keeps repeating, right? So this part of the number, 2.34, is not part of the repeating. So I'm going to separate that and then start adding on the repeating part. Remember, if you lined up the decimal points and started adding, wouldn't this right here generate that right there? Lucy?
Wait, sorry, you just adding, when you're doing the repeating part, are you just adding 1 0 to it every time? Like, so the
I need to be able to add these, Lucy, and get that.
Okay.
So does that make sense?
Yeah.
Yeah. Let's think about it and not try to memorize stuff because that's not going to work. You got to think about it. Okay. Now, this is geometric. This part of it's geometric. What's the ratio? Lucy just told you. No. The ratio is 0.1. I am adding, not really adding, but another 0 is appearing each time because I'm dividing by 10, which is multiplying by 1/10. So this has a ratio of 1/10. This is geometric. This is going to go on forever. Infinite geometric. So the sum of all of that is the first term over 1 minus the ratio, which I'm going to write as a decimal since that's a decimal. So that's 0.005 over 0.9. Well, I'm supposed to be writing a fraction, but I'm not supposed to have decimals in my fraction. So if I move that decimal place, multiply by 1,000, in other words, I'm going to have 5 over 900. That's what this number is right here. Now that is this. I still need to add on this, which is 234 over 100, if I write it as a fraction. So now I have the fraction that came out of my infinite part, the fraction that came out of the non-repeating part. So I'm going to get a common denominator and add those together. My denominator will be 900. So I have 5 900ths plus 2,106 900ths. So the final answer to the problem is going to be 2111 900ths. Right? And since I have a calculator, I'm just going to type in 2111 divided by 900, and what better happen when I do that? I better get that, and sure enough I do. Okay? Alright, Darren?
Can we go over homework problems for 9.5?
I don't care.
Yes?
I don't
Okay.
care.
Could we do 3A
On what homework?
9.5?
3A says write in summation notation.
Yeah.
Now, summation notation means sigma. I always start my sigmas with 1, but you don't have to. I think it's easiest to start it with 1. And I need the general term, or the, what we call the explicit term for this sequence. Well, what is going on in this sequence? We're multiplying by -2, so it's geometric, and the geometric formula is this. So my first term is 6, my ratio is -2 to the n minus first, and since the sequence goes on forever and ever, there's no end to it, I'm just going to leave that empty, or put an infinity up there, whatever you want, and that's the answer.
Okay.
That's it. All right, so what else do we have? Tess?
Do you do 7 on the quiz?
Well, I don't know what quiz you have.
9, 1, and 9, 3.
No, I don't, so, wait, were they all the same? I
I think
can't.
they're all the same. They're all the same.
Are they all the same? All right, 7 on the quiz. How many ways can 9 blue, 6 gold, no class, blue beads are identical? All right, so 9 blue, 6 gold, and these are all the same. And I'm putting them on a bracelet with no class. That means it's a perfect circle. How many beads are there? There are 15 beads, but in a circle, that's going to be 14 factorial. These are all the same, so that's 9 factorial. It's a handheld circular permutation. It's a necklace, bracelet, or keychain. So I have to consider reflections, divide by 2. That should be the answer.
So if there were to be a class,
Then it'd be 15 factorial.
okay.
What does a class do? Makes it a line. Right?
Exclamation mark.
Sydney?
Sorry, why'd you multiply by 2?
It's a reflection. That means I can look at it from both sides and I can count both as order. All right, who else? All right, go ahead, Maren.
Number 8 on 9.5, the homework, what was that asking us to do?
Number 8 on the 9.5 homework is asking you to add it up. All those numbers, add them up. But those of you that are on your toes, paying attention, coming to class, watching videos, doing all the right things, know that it can't be added.
Okay, good.
It can't be added because what's the ratio here? 2 greater than 1. So there's no sum. It's not possible.
But can, like, if I wrote can't add, like, infinite, that's an okay answer?
It's not summable. That would be the best answer. Or can't add. That means the same thing. Okay, what else? We need to pay attention to that review sheet, folks. We also, let's look at the 9.4 homework number 1. We should be cranking out these limits without a second thought. Some of you, I don't even know what you're what you're thinking. Problem A, what's happening in that sequence? No limits, not addable, or it's not, there's no limit. It just keeps getting bigger and bigger and bigger because you just keep squaring bigger and bigger things, right? So it's divergent. That one is divergent. It does not have a limit. On the other hand, what's happening to B? The limit's 0 because those terms are getting smaller and smaller and smaller. What about C? It's also 0. Now, it is not geometric or arithmetic. There's a pattern, but the terms are getting smaller and smaller, so the limit is 0. What about D? No limit, divergent. Think about that. If you let n be 1, you get 2. You put in 2, you get 5. If you put in 3, you get 7. What is happening to those outputs? They're just getting bigger. So there is no limit. What about E? -1. That one we shouldn't miss. It's 3n over -3n. The limit is -1. What about F? 2. Again, we shouldn't be missing those. G, the limit is 0. When you raise a number less than 1 to higher and higher powers, the limit is 0. And what about H? No limit, because when you raise a number greater than 1 to higher and higher powers, it just explodes. Yeah. All right, anything else from the review sheet? I just had to remember I graded those. Good. Anything else from the review sheet we need to look at? Liam?
13C.
13C is a sigma, so what does a sigma always mean? Yoo-hoo! What does a sigma mean? It means sum, and this is going to be an infinite sum. So the first thing I got to think about is, can I do it? Can this be added? And the answer is yes, because what is happening to these terms? See that guy right there? Just going to keep getting smaller and smaller, so it's definitely addable. So my formula says I need the first term. That's easy. Just plug in 1. What is 3 times 1/2? 3 halves or 1.5, however you want to write it. 3 halves or 1.5. It does not matter one bit, whatever's easiest for you. Then I need my common ratio. Now, again, those of you that are tuning in here, really tuning in, know what the ratio is right now. If you don't know what the ratio is, then you got to work on a few terms to figure it out. If you put in 1, we already said we get 3 halves. What if we put in 2? Think of this as a 1/2. What if we put in a 2? We get 3/4. If we put in a 3, we get 3/8. So at this point, you ought to be able to see what's going on. The ratio is 1/2. It's that number right there. The ratio is 1/2. So, here. So my first term was 3 halves. My ratio is 1/2. So it looks like this sum is going to be 3. Right? That's all there is to it. Don't make them harder than they are. These should be easy for you. At least those times should be.
Wait,
All right, what else?
this
Aaron?
is just a general question. When you're doing like the sum formulas in like SN equals N over 2, stuff like that, is your N
The number of terms you're adding up.
not the last term?
A sub n is the last term, but n is the number of terms you're adding up.
Oh, okay, okay.
Haley,
I see.
on the review sheet, number 18, we already did. It's in the video, watch it. All right, what else? George?
You have 2A on homework 9-5.
9-5, 2A. Yeah, it's just like this one, except it's not going to be geometric. So again, some of us know exactly what's happening here, some of us don't. So we have to see what's happening. So we're gonna put in 1, and what do we get? 1. So we put in 2, and what do we get? 4. And then we put in 3, and what do we get? 7. And we're gonna go, I'm not gonna write them all out, but we're gonna go all the way till we plug in 10 and get 28. Now, what's happening here? Okay, and when you say plus 3, you're telling me it's arithmetic. What does sigma always mean? So you have a formula to sum an arithmetic sequence. It's right there. So you just plug in what you know. Well, how many terms are we adding up? I didn't write them all out, but how many are we adding up? 10. So 10 over 2. What's the first one? You already figured it out. The first one is 1, and the last one, you already figured out, is 28. Whatever that is, when you work that out, that's the answer to the question. Oh, I know what it is. It's 145.
Can you do 9 on the review?
9 on the review sheet. And a random check on an assembly line. The probability of finding a defective item is 0.003. So pretend you're the worker on the line, you pick up an item. 0.003 is the probability of defective. What is the probability then of not defective? Okay? One or the other, right? One or the other. So find the probability of a non-defective item occurring 10 times in a row. So in other words, you're going to pick up 10, you're going to do this experiment 10 times, you're going to grab one 10 times, and every single one of those 10 is going to be non-defective, right? Non-defective. So 10C10, I'm going to run 10 trials, and all 10 of them are going to be non-defective. And 0 of them are going to be defective. You don't really need this part since it's just 1, but that I always put it in to kind of, so, yep. So that's it. So if it said 1 was defective, then it'd be 10C1. Now, if it said 1 was defective, then you could do 10C1, but remember, the 1 is going to go on the 0.003, right? Because that's the defective probability. Okay? You just type that in. All right, Josh?
10 on the review.
A fair coin is tossed 5 times. Find the probability of obtaining 2 heads and 3 tails. So this is kind of the same thing. When I toss a coin, the probability of a head is 1/2, and the probability of a tail is 1/2. If I do it 5 times, I'm going to get 2 heads. Now, obviously, if I say I'm going to get 2 heads, that automatically means I'm going to get 3 tails. So I'm not going to worry about that part of my setup. I'm going to go with 2 heads. So 5C2, I'm tossing it 5 times. 2 of them are going to be heads, which automatically means the other 3 are going to be tails. Now, if you did this problem from the tails standpoint, I did it from the heads. I said 5 tosses, 2 heads. If I did it from the tails, it would be 5C3, 3 tails, 2 heads. But remember, Pascal's triangle, which is where these numbers come from, is symmetric. So if we looked at the 5th row, this is 5C2, and this is 5C3. Doesn't matter. If there's only 2 options, then it's not going to matter. So either one of those will give you exactly the same answer. And in fact, this coin tossing stuff is the way Pascal originally started looking at the triangle in terms of the possible outcomes.
I just had a question about the last one. How do you know when you use like 10C10 or like 10C1?
Well, it depends how many you want. In this case, we want it all to be not defective.
So you use
So 10C10. if I wanted
Oh, so it's how
one,
many you want?
yes, if I wanted
Second
one
number.
to be defective, then it would be 10C1. All right, what else? Yes, Dom?
On the review sheet, can you do either 13B or 13E?
13. Which one?
Either D or E.
Pick one, I don't care.
E.
All right, we're doing E. All right, it's another sigma. So sigma means sum, it says evaluate. Okay, now the problem is, this is not, well, luckily it's not infinite because I couldn't add it if it were infinite, but there's an ending point to it, some n, but I don't know what that is. So I'm going to go back and think about my summation formulas that we looked at, that they're on some notes somewhere. I don't know if I have those notes anymore, and I don't have those memorized. I need my who's got my summation formulas handy?
I have.
Steal them here from Chris. Okay, so this, I'm gonna pull that coefficient off. Because I always keep the coefficient out in front. And now I'm gonna use my summation formula for this. So that, for k squared, on my sheet, it says n plus 1, 2n plus 1 over 6. And remember, n is this number right here. So if this were a 10, then this would be 10, 11, and 21. Since it's an n, I just have to leave it in. So the 3 will cancel this and make it a 2. And that's pretty much all I can do, other than FOIL it out. Okay? Thank you. All right, what else?
This is just a question on that. On like the test, would you want us to FOIL it out, or could we just leave it like that?
Just leave it out. I mean, if stuff's gonna cancel, like if you had n plus 1, n minus 1, that would be easy, but this is just gonna be a big trinomial. If you want it, doesn't matter, but you don't have to. Okay, Liam?
Homework 9-4, number 2.
9-4, number 2 says, the fourth and seventh term of an arithmetic sequence are, so fourth is -8, and the seventh, fourth, fifth, seventh is 4. Find the first term and a recursive rule for the nth term. Now, it tells me it's arithmetic. If it didn't tell me that, I'd be in trouble. But it tells me it's arithmetic, which means what is happening? I am adding something 3 times, 1, 2, 3, to get from -8 to 4. Now, from -8 to 4 is a plus 12, right? So I am adding something, an equal thing, 1, 2, 3 times to get 12. So what am I adding? I'm adding 4. So this number would be -4, this would be 0, and that would be 4. Now go backwards. So this term will be -12, -16, -20. So one of the questions was, what is the first term? Right there it is, the first term. Then it says, write a recursive rule for that. Now, the explicit rule for this would be using this formula. It's arithmetic, but that isn't what we're doing. It doesn't say write an explicit rule, it says write a recursive rule. You already know what it is. How did you get from here to here? Plus 4. So take a term, add 4, and you get the next term. That's your recursive rule. But you've got to remember, in every recursive formula you ever write, you've got to be sure you say what the first term is, because that's what gets them all rolling. right, Lily?
Will it always be a n plus 1? Will it always be that?
The term after this term is gonna be the n plus first term. They're consecutive.
I was wondering, what formulas do we get? Do we get any?
You get the sequence, you get all the summation ones, the three, what are the three of them there? And then you get the, A sub n and S sub n's that have been in your notes.
What about these summations? These ones right here,
Okay, who said that?
or the other ones?
Okay, I said you get the three summation formulas, and then you get the A sub n and S sub n formulas.
Oh, okay, I didn't hear the S sub n, sorry.
So, when I did this one, the homework, I got A of n, A sub n equals A sub n, like, minus 1 and the sub plus 4. Would that be counted correct on the test?
That pattern is correct.
Okay.
The problem is, what part did you add here?
I did the same thing, I forgot to put the first one.
Okay.
But here's the problem. When you use this notation, then this has to be A sub 1.
Okay.
So you're starting out by letting n be 2.
Okay.
Instead
So
of
don't do
starting
that.
out by letting n be 1. You're
Okay.
starting out with this. So this is better,
Okay.
if this is the right pattern.
Okay.
That's exactly what's happening.
Homework 9.4, the limits of 1e.
What problem are you on?
Homework 9.4?
Yeah.
Number 1.
I just went through all those. We literally just went through those, Maren.
Okay.
Am I imagining this? Didn't we go through those? I think we did, yeah. Okay, what have we not done? We need to focus on problems we haven't already done. Tess?
Could you do 4B and the 9.2 homework?
On the what homework?
9.2.
9.2 homework.
9.2.
4B. This is a formula test. Do you know your combination formula?
I did that, I got it wrong.
Well, I tried to, you didn't do it right. What does your formula say? What does your formula say? What are we supposed to do? So this guy, factorial, is the top. And then I'm going to subtract those two. So that's going to be n plus 1 minus r minus 1. Remember, you are subtracting this minus this. So that's going to become minus 1s. Right? And that's factorial. And then it's also over r plus 1 factorial. That's the combination formula. So we have n plus 1 factorial over what? What do we have in the bottom? N minus r factorial, r plus 1. Okay? All right, what else do we need to look at? Lucy?
On the 9.3 homework, can you do number 6?
Two cars are selected at random, so my denominator is going to be 25C2. Because what is the denominator of every probability problem? Total? How many total cars do you have? 25. How many total are you picking? 2. So that's the denominator. Now the numerator is what we want to have happen, which is what? I want both of them to be big bombs. How many big bombs are there? 20, and I'm picking 2. There's your answer, that's all there is to it. It's like a card problem where you're gonna pick 2 queens. And this time I'm picking 2 big bombs. All right, what else, Don?
Number 8 on homework 9.2.
9 to number 8. Okay, again, these are formulas, guys. gotta know our formulas, so this notation is combination notation. So that means NC n minus 2. So what's the formula for that, Dom?
N factorial over n minus 2 factorial.
So it's gonna be n minus, so n minus n plus 2 factorial, and then,
n minus 2.
yep. So that's gonna, okay, is that, okay, I gotta add that to something. What am I adding that to?
N plus 1 c.
So n plus 1 factorial, and then,
N plus over n plus 1.
I'm gonna subtract, so that's gonna be n plus 1 minus n plus 1.
Yeah.
So that's gonna be 2 factorial. And then I need that guy, so n minus 1 factorial. And with any luck, it's all gonna work out to be n squared. Right? Well, what, this is just 2 factorial. What's n factorial? N, no plus in here. N minus 1, n minus 2, n minus 3. So what's going to happen? Everything after, from the n minus 2 on is going to be gone. So I have n minus 1 over 2. 2 factorial is 2. That's all that's left in the first fraction. All right? What's n plus 1 factorial? N plus 1, n minus 1, n minus 2, da. So the only thing that's going to be left here is the n plus 1 and the n, because everything else is going to cancel with this guy, and that's over 2 also. On here. So that's n squared minus n plus n squared plus n all over 2. They have a common denominator, so I can go ahead and add them. 2n squared over 2 is indeed n squared.
Wait, why did I simplify the answer to why the total to n plus 1 and n minus 1?
We can, but these are ours. We're never going to get an hour up here on the top, right? Maren?
Can you explain on homework 9.4 what number 8A is asking?
8A is saying which of the following rules will define a geometric sequence. So which of them are geometric?
That's what that's asking?
Yeah. It says which of them are geometric.
Like which of the following rules?
So is the first formula going to generate a geometric set of numbers? No, because you're adding 3. So there's no way that's going to be geometric. What's the second one doing? Subtracting 3. That's not geometric. What's the third one doing? Okay, dividing by 3 is the same as timesing by 1/3. C is geometric because you're timesing by 1/3. D. No, that's cubing. How about E? Yeah? Because what are you doing in E? You're multiplying by 3. Different powers of 3. So actually C and E are the correct
What would you call
answers.
What would you call D then? Is that a whole other thing?
There's arithmetic and there's geometric and that's all there is. So the other things are just the other things. All right, what else? Yep.
9.3 number 1.
In a class of 27, all of the students either like chocolate or strawberry ice cream. 18 like chocolate, 17 like strawberry. What's the probability of choosing a student if he likes only strawberry? What's going to be our setup here? How are we going to look at this problem? We're going to look at it as a Venn diagram because that's what we do when we have overlapping sets of numbers. Mrs. Ford, how do you know they're overlapping? 18 like chocolate and 17 like strawberry. What is that? 35. How many kids are in the room? 27. Obviously they're overlapping. How many kids like both? remember, it says all of them like one or the other. So there's nobody out here to worry about. Everybody's in the circles. And there can only be 27 people in the circles. So if 18 like chocolate, then there must be 10 that like only chocolate. And if 17 like strawberry, there must be 9 that like only strawberry. Now look, what do these numbers add up to?
27.
Yeah, which is exactly what they're supposed to add up to. Now I'm going to reach in the box and grab one kid. Remember, there are 27 kids in the box. So my denominator is 27. I'm grabbing one kid and I want him to like only strawberry. There's 9 of those, so my probability is 1/3. Now, you could set it up as 9C1 over 27C1. You can do that if you want. It's the same thing. If that makes more sense to you, when I'm only picking one, for me, it's easier just to do the fraction. Okay, what else? What other questions? We have a test tomorrow. Or whenever we have a test, Friday, whenever our next class is. All right, come on, Liam.
I just wanna know, like, how to answer on 9-4, number 7, true or false. How do you want us to write this? Like,
Wait, true or false? If the first 2 terms of an arithmetic sequence are positive, then so is the third. Justify your answer. Well, what did you say it was?
I said true because it's gonna add the same number each time.
Well, so you missed it. I mean, you got the wrong answer. That's why it's marked wrong. Because you're right that I add the same number every time, but do I have to add a positive number every time? So if I start with 10 and add -7, what's going to happen? The terms are going to get negative. Instead of, because I'm smart,
Trust me. That's
just
reasoning.
trust me.
That's my reasoning.
You lost a point for that, by the way.
Did you write that?
He did.
Because I know I said just trust
And
me.
I think he thinks I don't look at the homework or something, because he literally wrote.
That is so cringe.
Bro, that's my reasoning.
All right.
Wait,
All right, who else? Who else?
really quick.
Mary?
On 6 on 9.4, is the answer 134217728 cents?
Yes.
Except we would change that to dollars.
Oh, okay.
I
'Cause there
mean-
was just a big question mark written next to my cents.
Probably because you wrote cents, and I'm like, come on, who? I mean, do they talk about the
But is that
national
wrong?
debt
I
in
wrote
terms of
cents,
cents?
But it's not wrong.
No, but on the test it would be -1/8 or something, because it's not logical. Come on.
But the whole thing is in cents. You have to think of the
Yes, because we can talk about 2 cents,
Okay.
and you can talk about 8 cents. We don't talk about 103 million cents or whatever it is. All right? Stop it. Here we go. What else? What else? We got better things to talk about here. What else? Zoe? 9.2 homework. What question are we looking at, Zoe? 9.2 number 3 says find the coefficient of this term of this expansion. So what you have to really pay attention to here is the expansion has an x squared in it. So if we know what the coefficients are. The coefficients, generally speaking, are going to be 10C10, 10C9, 10C8, and so on, all the way down to 10C0. Those are the coefficients if I wrote out the whole thing. Now, what I need to do is figure out where the term's going to be. When I take, let's say I take this one, and I put my 2x squared and my y to the 10th power, that power, and this one would be 0, that power is actually going to be x to the 20th. So I gotta figure out where is it gonna happen that when I simplify, I actually get x to the 6th. Now, it might be easier to think about it in terms of y's, because the y doesn't have that. So if you think about the y's, down here, this one is y to the 10th, and then 9, and then 8, and then 7. So isn't it the 4th term from that end? So 10c 0, 1, 2, 3. So this is going to be 10c3, and then 2x squared, y. And if that's a 3, and that's a 7, and I know that's a 7 because I counted, then that will give me my x to the 6th. So I need to figure out what 10c3 is, and then I need to multiply it. It's 120. And then I need to multiply it by 8, and then I'm gonna have my x cubed y to the 7th versus 6. So that's gonna be what, 960? Would be my coefficient. Does that make sense to you?
So when you find the coefficient, like the c's, you start like
Well, not normally. We did this time because this was a square, and that was gonna mess up my powers. So my powers are actually gonna be 20, 18, 16, 14, which is unusual for us because I had power on there before.
I'm sorry, you've explained this a bunch. How did you get 120? And you get
It's 10c3.
10c3, so we take 2 to this, 2 to the 8.
2 to the 3rd,
2 to the 3rd.
which is 8.
Yes.
And then I multiply that number in my problem, and then I have my original number, which is 120. Then I multiply it. On the review sheet, which one?
On the review sheet.
33 on the review sheet. If the sum of a red die and a green die is 8, what is the probability that one of them is at least 5? Okay, so I've got my red and my green die, and the sum has to be 8. So what can happen to get a sum of 8? I can have a 6 and a 2, or a 2 and a 6. I can have a 3 and a 5, or a 5 and a 3. I can have 2 4s. Would everybody agree with that? Is that it? To get an 8? Now, it says, what is the probability that one of the die shows at least a 5? Now, first of all, how many possible outcomes are there? 5. So your denominator's 5. How many of those have one of them being at least a 5? Well, this one, and this one, and this one, and this one, right? So what's your probability? 4 out of 5. Because they tell you it has to be an 8. 25. 25. To complete, you must pass 2 classes. If you decide to choose your classes at random by drawing 2 class names from a box, what is the probability that you will take racket sports and rhythmic activities? All right, so how many classes are there altogether to pick from? 1, 2, 3, 4, 5, 6, 7, 8. Are there 9?
Yeah.
And you're going to pick 2 of them. So your denominator is 9C2. You're going to pick 2 classes. We don't care what order we pick them in. We're going to pick 2 of them. Now, what's my numerator? It is what I need to have happen. I need to pick racket sports. There is 1 racket sport, and I have to pick it. And there is 1 rhythmic activity, and I need to pick it. It's like if you had 10 balls in a jar and you were going to pick 2, what's the probability of getting 1 red and 1 green? Well, this would be your 1 out of the reds, your 1 out of the greens, and then 2 out of the total on the bottom. Yes, the top is just 1. Yeah, I wrote it out longhand, but it is just 1.
No, I understand that. I just like thinking about it.
That's
Sometimes
the only thing you want to have happen is you get those 2 classes. So
yeah, no, it makes sense. It's just sometimes you gotta you're picking 2 things, like when you pick one. That's why it's like
that's no pair. All right, one more. Let's go. What else? What is our last question? Let's make it a good one. Peter? 27 on the review sheet. All right, so 2 pre-calculus sections, able and bonnets, and girls, boys, boys. 1 student chosen at random happens to be a girl. What is the probability she is from able's class? So, what we're trying to find out is, what's the probability of able given girl? So, if we get a girl, what's the probability she is from able's class? So, we want the probability of able given girl. Any ideas about how we might set this up to find these probabilities? Tree diagram, absolutely. So you go to pick a classroom. Aren't these 1/2 and 1/2? I mean, I'm gonna pick a girl, be in either class. Now, I've got boys and girls in both classes. So this is teacher B, and then this is boys and girls. So in Abel's class, there are 20 kids altogether, and 12 of them are girls. So 12 out of 20 and 8 out of 20 would be your probabilities in cookie jar A. And then in B, there's 25 kids, 10 girls, and 15 boys. So, our formula for this is the probability of both divided by the total probability of girls. So the probability of A and girl would be right here. Would you agree with that? Yeah. So that is 1/2 times 12/20, which I'm sure reduces to something, is that 3/10? So my numerator is 3/10. Now, what's my denominator? All the girls. So it's this 3/10, but it's also this one, which is 1/2 times 10/25, which is 1/5. Is that right? So my denominator is 3/10 plus 2/10, which is 1/2. Because that's the total girls. This one and this one added together, if my arithmetic's right, that's 1/2. So your answer is 3/10 times 2, which is 3. All right, next time I see ya, we'll do that. Let's get ready for prayer. Please don't get your phones out. We're praying.